Hello dear student, welcome to the session. In this session, we are going to discuss a very important topic from the chapter Ray Optics, that is lens maker's equation. It's a very important topic from competitive exam point of view. So, let's see what is lens maker's equation. Lens maker's equation is used to find the focal length of a lens or power of a lens. Okay, so let us consider first of all a convex lens. So this is a double convex lens. Let us take R1 as the radius of curvature of its first spherical surface, and let us take R2 as the radius of curvature of the second spherical surface. Okay, and let us consider this as a equiconvex lens. So the radius of curvatures will be same for both the spherical surfaces. Okay, now how will you write the lens maker's equation for this particular case? Yes, the equation is given by 1 by f. What is f? F is the focal length of this lens. So 1 by f is equal to NLM minus 1. What is NLM? Refractive index of lens with respect to the surrounding medium. Okay. So in this equation, NLM is nothing but NL divided by NM. Refractive index of lens divided by refractive index of that medium. Okay. Into the next term is 1 by R1 minus 1 by R2. This is the lens maker's equation. Okay. Now, for this particular case, I told you we are considering it as a equiconvex lens. So, both the surfaces will be having the same value of radius of curvature. But when you are substituting the values in this equation, you have to be careful. You have to apply proper sign convention. Okay. See here. Here R1 is measured towards the right. So, you have to give a positive sign for that radius of curvature. But R2 is measured towards the left. So, R2 should be equal to minus R. Okay. So, we can write this equation as NL by NM minus 1 into 1 by R minus 1 by minus R. Okay. So, the equation becomes NL by NM minus 1 into 2 by R. In this way, you have to apply proper sign conventions. Okay. So, if you consider that the lens is surrounded by air, then the refractive index of the medium would become 1. We know the refractive index of air is 1, right? So, you can simply write the equation as NL minus 1 into 1 by R1 minus 1 by R2. Okay. Now, let us consider the case of a concave lens. Let us consider a double concave lens. Okay. So, let us consider this also as a equiconcave lens. Both the spherical surfaces are having the same radius of curvature, but here the radius of curvature of the first spherical surface is measured towards the left. So, R1 should be taken as minus R, and the radius of curvature of the second spherical surface is measured towards the right. So, R2 should be taken as positive R. Now, when you substitute in the equation becomes 1 by f is equal to NL by NM minus 1 into 1 by minus R minus 1 by positive R. So, this becomes NL by NM minus 1 into minus 2 by R. Is it clear? Okay. So, not only convex and concave lens, we'll be having other type of lenses also when you're doing the numericals. We will have plano convex lens, plano concave lens, etc. Read the first question. A lens having refractive index 1.6 has focal length of 12 cm when it is in air. Find the focal length of the lens when it is placed in water. Take the refractive index of water as 1.28, and we need the answer in the unit millimeter. So, what are the given data? Yes, we are having a lens which is having a focal length of 12 cm when it is kept in air. Okay, and what you have to find is the focal length of the same lens when it is immersed in water. Okay, the refractive index of lens is given, refractive index of water is also given, and we already know what is the refractive index of air, that is 1, isn't it? So, we have a shortcut equation for solving this kind of question. This is a very common question in entrance examinations. In air, we can apply Lensmaker's equation, that is 1 by FA. FA represents the focal length of the lens in air. Okay, 1 by FA is equal to NL minus 1. No need to write NL by NM because the medium is air. We know the refractive index of air is 1. So, NM will be equal to 1. Okay, so NL minus 1 into 1 by R1 minus 1 by R2. So, this is the equation to find the focal length of the lens when it is kept in air. We can mark it as equation number 1. Now, when the lens is kept in another medium, then the new focal length, let it be Fm. Okay, so we can apply Lensmaker's equation. 1 by Fm is equal to NL by Nm minus 1 into 1 by R1 minus 1 by R2. There will be no change in the curvatures of the lens when it is immersed in the medium, but here you have to include the term Nm also, which represents the refractive index of that particular medium. Okay, so here the medium is water and the refractive index of water is given as 1.28. So we can give the substitution for Nm as 1.28. Now mark it as equation number 2. Now you just divide equation 1 and equation 2. What will you get? Fm by Fa is equal to NL minus 1 divided by NL by Nm minus 1, isn't it? So from here you can write the equation to find the focal length of the lens in the medium as Fm is equal to Fa, that is focal length in air, into refractive index of lens minus 1 divided by refractive index of lens with respect to the medium minus 1. So you can keep this equation as a shortcut equation for solving these kind of questions. Okay, what kind of questions? If the focal length of a lens in air is given, can easily find out the focal length of the same lens in another medium if the refractive index of both lens and that medium are given. Okay, so now we can solve this question using this equation very easily. Now this has become a direct substitution question. So let's go to the solution. So now we can directly substitute all the values given in the question. What is Fa? Focal length of the lens in air is given as 12 centimeter. So 12 into refractive index of lens is given as 1.6 minus 1 divided by refractive index of lens divided by refractive index of water, that is given as 1.28. Okay, so you will get 12 into 1.6 minus 1 is 0.6 divided by, what is 1.6 by 1.28? It is 160 divided by 128. You will get it as 10 divided by 8, which is nothing but 5 by 4. So 5 by 4 minus 1, and 5 by 4 minus 1 is 1 by 4. So you will get it as 28.8 centimeter. It is in centimeter only because you are substituting the value of Fa in centimeter, right? Now we have to convert it into millimeter. Just by multiplying with 10, you will get the answer as 288 millimeter. So answer for this question is option C. Okay, so you just by heart this equation. This is a very simple equation. This is the equation to find the focal length of a lens when it is immersed in a certain medium. Okay, the focal length of the same lens in air will be given. The refractive index of the lens as well as the refractive index of the medium will be also given. You can easily find out the answer. Hope the solution is clear. Now let's move on to the next question. Read the question. A concave or convex lens of refractive index 1.5 and radii of curvature of its surfaces are 30 cm and 20 cm respectively. The concave surface is upwards and is filled with a liquid of refractive index 1.3. The focal length of the liquid glass combination will be. So here it is a concavo-convex lens. So it is a concave convex lens. That means one side is convex and the other side is concave. That means it should be curved inwards like this. Okay, and it is given in the question that the concave surface is upwards. Yes, so the picture is correct. The concave surface is upwards and it is filled with a liquid of refractive index 1.3. This portion is filled with a liquid which is having a refractive index 1.3. Okay, so what you have to find is the total focal length of this liquid glass combination. Okay, so you can consider this much portion where the liquid is filled as a plano convex lens. Okay, so first of all, let us write an equation to find the focal length of that part. Using Lensmaker's equation, we can write 1 by f1 is equal to NL minus 1. NL is 1.3, so 1.3 minus 1 into 1 by R1 minus 1 by R2. See here, what is R1? The radius of curvature of this spherical portion, which is given in the question as 30 centimeter, right? So this is 30 centimeter. And what is R2? That is nothing but the radius of curvature of this plane surface, which is always infinity, isn't it? So we can substitute R1 as 30 centimeter and R2 as infinity. So here you will get 0.3 into 1 by 30. 1 by infinity is 0. So 0.3 divided by 30 will give you 1 by 100 as the value of 1 by F1. Okay. Now, what about the refractive index of glass? It is also given, right? What is that? Yes, it is 1.5. Okay. The refractive index of this lens is 1.5. So, there also we can apply the Lensmaker's equation to find the focal length. Let the focal length be f2. So, 1 by f2 is equal to ng, that is 1.5 minus 1 into, here what about the values of R1 and R2? Yes, here the radius of curvature of this face is given as 20 centimeter. Okay, so we can substitute 1 by 20 minus 1 by 30. See the sign conventions also, both are measured towards the same side. Okay, so what will you get here? 1.5 minus 1 is 0.5 into this will give you 10 by 600, that is 1 by 60. Okay, so this will give you 1 by 120 as the value of 1 by f2. Okay, and what you have to find here is the focal length of the liquid glass combination. So when you have two lenses in contact, you can find the focal length of the combination by taking 1 by f1 plus 1 by f2, right? So just take 1 by 100 plus 1 by 120. Solving this, you will get it as 11 by 600. So that is 1 by f. So what is f? F is finally 600 divided by 11 centimeter. Okay. So the answer for this question is option B. Yes, read the next question. Two identical symmetric double convex lenses of focal length f are cut into two equal parts L1, L2 by AB plane and L3, L4 by XY plane as shown in figure respectively. The ratio of focal length of the lenses L1 and L3 is. See, you obtain L1 by cutting the lens along a horizontal plane AB. So the piece L1 is like this, isn't it? L1 as well as L2, they are having no change in focal length. Okay, because there is no change in the radius of both the spherical surfaces even after cutting. So this piece will have the focal length which is same as that before cutting. So we can write the equation of that focal length using Lensmaker's equation. 1 by f is equal to n minus 1 into 1 by r minus 1 by minus r. Isn't it? By applying the sign conventions. So here you will get 1 by f is equal to n minus 1 into 2 by r. Let us mark it as equation number 1. Now when the lens is cut along a vertical plane xy, there will be a change in its focal length, because when you consider the part L3, it has now become a plano convex lens. Okay, so the radius of curvature of the first spherical surface, you can take it as positive r, but the radius of curvature of the second surface, which is a plane surface, will be infinity. Now, when you write the focal length of this piece, you will get 1 by f dash is equal to n minus 1 into 1 by r minus 1 by infinity. So, this will give you 1 by f dash is equal to n minus 1 into 1 by r. Mark it as equation number 2. So, just compare equation 1 and equation 2. it is very obvious that f dash is double f, isn't it? Now, when you take the ratio of focal length of the lenses L1 and L2, you can write f divided by f dash. So, from this relation, f divided by f dash will give you 1:2. Okay. So, the answer for this question is option A. Hope the concept discussed in this session is well clear to you. So, lens makers equation is a very important topic from entrance exam point of view. Hope the questions discussed are also clear. So, practice more and more questions from this concept. Thank you.